Okay, thank you very much for this exciting conference and for your previous talks. It's really good. I think I have a little bit of a different perspective to, I mean, it's a bit less about aesthetic appreciation, but I hope it can contribute to the discussion in later on as well. And also, it is quite a preliminary work, so it's quite it's more like using Bayes' rule, which is well established and predictive in lots of modeling and in cognitive science. But I would like to see how it could, that kind of thinking, how it can translate to experiments in psychology of music, and how we can update certain models about how we conceptualize and also investigate emotion as well as multisensory associations with music. So to start with emotion perception in music, well, it is in many ways probabilistic rather than deterministic. So what emotion is perceived is often ambiguous. Certain features of the music like tempo, mode, and intensity are, well, increase the likelihood of one emotion to be perceived rather than another. But still listeners might be hesitating between emotions, so emotions may compete with each other. And contextual factors prime or influence which emotion is more likely to be perceived. The very well-known model of emotion perception is so the lens model by Patrick Joslin originally, which is later also adapted by others, assumes at the center acoustic features, so dynamics, rhythm, timbre, etc. And depending on their values, a certain emotion is more likely to be perceived. So that's decoding from acoustics to perception. And a performer would encode. So a performer might have an intention to express an emotion, and that encoding of that intention is done from an intention to acoustic materials. And similarly, we could talk about a composer encoding an intention into musical features. And of course, this is then probabilistic to in the sense that certain emotions might be more or less plausible, likely to be perceived. But if we look at Bayes' rule, we can add competition between emotions as well as a contextual priming. So a very simple explanation, I think, of Bayes' rule is to assume, so what is the probability of hypothesis H given Q C? So what, and we can say this immediately maybe in the terms of emotion and cues, so musical cues. What is the probability of an emotion given a certain cues, given a certain tempo, for example? Well, according to Bayes' rule, this is equal to the probability of that cue in a given emotion, multiplied by the probability of that emotion to happen in any kind of circumstance, irrespective of cues, divided by the probability of a cue happening in any kind of context. So the perception of an emotion is not only a function of the values of certain cues, but it's also a function of the probability of the emotion in musical contexts and the uniqueness of the cue to differentiate emotion. And I think that, those probability of the emotion and the uniqueness of the cues are two very simple things that we should also take into account into perceptual experiments and see how that might differentiate, for example, differ between cultures or genres. And in this illustration, in the sense of how such a Bayes rule works, application of it, this is an adaptation of a figure by Sadakata et al. The original wasn't about emotion, but I put emotion labels on it. It seemed to work really quite well. The top shows the frequencies of a cue, for example, duration. So from on the x-axis, it's from very short to very long, so from fast to slow. And and the y-axis gives the probability density. So how frequent a certain cue happens in different emotion contexts. So we instruct a performer to play angry, sad, or happy. What kind of tempos are chosen? Then this, in the middle panel, you see the multiplication of those density curves by the prior probability of emotions. So for example, angry is not so likely in the context of music, less likely than, for example, happy and sad. And those are then adjusted. And the final, the bottom panel shows the probability then of the perception of each emotion given a certain cue. Then so what becomes part of the interest is indeed to think about what is the probability of emotions in musical contexts. And one way of investigating that is to look at how often certain emotions occur in the context of music. And this, for example, Patrick Jocelyn has done these experience sampling studies in comparing which emotions are occur in when music was also on, and comparing that to everyday emotion contexts. And then calm, contentment, happiness, so positive emotions seem to be more often occurring than some other emotions. We can also look at perceived emotions, and so I'm drawing here from a very famous study by Lauka and colleagues, comparing the expression of 11 emotions in 3 different kind of cultural contexts. So in Sweden, the study was done in Sweden, Japan, and India. And musicians, so Swedish, Japanese, and Indian musicians were asked to participate, and then also listeners from those countries were asked to evaluate those performances. So the musicians performed improvised pieces with 11 intended expressions, and the participants, the listeners, judged those improvisations and rated which emotion might be expressed. And this is then a confusion matrix, so it shows the accuracy, the percentage of identification of each kind of emotion. Now, the thing that I want to pull out here is indeed how often certain emotions are being perceived, and whether then certain emotions are more likely to be perceived in the context of any kind of music than others. And indeed, well, in this, so you get this profile of emotions, which is of course, yeah, sort of still very dedicated to this particular context. But as you see, sadness is relatively more often recognized, and other emotions are less often identified, particularly anger. And the interesting thing here is actually just to probably, or to explore whether cultural differences might be occurring in this kind of profile. And indeed, if we look at longing, there was a difference between the 3 different participant groups. So for Swedish participants, they were more likely to identify longing than the other 2 groups. So I think there is some potential to investigate the prior probability of emotions in different in musical contexts in different cultures, and that would be one. So the Bayes rule gives one way of actually including such information into the modeling of our emotion perception. And similarly, so the cultural and context dependent, so the probability of emotion might be cultural and context dependent, such as the example of longing here. Of course, the probability of a cue given an emotion might be cultural and context dependent. If, for example, the interpretation of a mode, certain modes are much more frequently used in different emotional contexts, so it's less signifying one particular emotion than so like minor mode is less signifying one particular emotion that in some contexts than in many well, the Western kind of cultures that we're probably used to, especially if you listen to pop music. And then the probability of a cue, the frequency of a cue, is also genre dependent. I could give an example here, but maybe so. This example might, again, it's relying on sort of corpus data that has been assembled by Jocelyn and Lauka in 2003. So they looked at how often certain cues, which cues are associated with which emotion. So performance studies, performers being asked to play angry, fearful, happiness, sad, tender, and whether they played with fast, medium, or slow tempo. And these numbers indicate the different studies that showed a certain association. So fear was in many studies coupled with fast tempo, and anger was also in many studies coupled with fast tempo. And so you could use this kind of data to indeed, estimate to predict the probability of that, for example, anger is perceived in the context of fast tempo, which is 0.3 if you apply the different probabilities. So not a very high chance, but still a reasonable chance. But if the tempo, the excerpt is also medium in dynamics, then suddenly the probability of perceiving anger in this based on this data is 0. There are no studies that show a medium dynamics in an angry kind of expression context. So this illustrates how this rule might be, this application of Bayes' rule might be different from other models that are regression models that are often used to predict emotion in the context of music. So Bayesian approach to emotion perception in music, it advances existing models of cue utilization. There's a potential for cross-cultural studies, so modeling differences in prior probability of emotions in music and modeling differences in variation of cues. These were very first kind of exploratory examples, and especially the details of applying the rules need further validation as well as good data sets to actually estimate priors. So the other aspect that I wanted to talk about is not only emotion, but also sensory motor associations, or actually multisensory associations as well as motor associations. So they're rich, or to actually broaden the scope of associations with music to beyond emotions. And so cross-modal correspondence is indeed one of those interests of mine, and I always quite like this picture of Peter Walker, a publication from him that shows how one sense modality, so the perception of high or low pitch, generates these corresponding kind of associations or corresponding characteristics in visual dimensions. So you would associate it with sharp objects, light rather than heavy objects, something fast moving, thin, bright, as well as small. And again, those studies are generally done. There are lots of experiments to demonstrate these kind of correspondences. So whether people are making them, there are some simple models maybe to estimate the size of those associations. But I've been wondering a while for whether it's possible to have some kind of systematic model for it. And I think Bayes' rule could be fruitfully applied again here. So it would read, what is the probability of a certain correspondence given a certain cue? And that would be the probability of that cue given the correspondence times the prior probability of the correspondence divided by the probability of the cue. And indeed, if we look at music, there are prior probabilities of certain prior probabilities of correspondences are higher than others. High in music are movement, emotion, but also spirituality. So how we use movement, music, it gives certain priors to make certain associations rather than others. And also in the case of sounds are, of course, as generated by objects and instruments with certain properties such as size, weight, thickness, movement, location, and gender. And then the prior probabilities of cues, well, it's the same as before in the discussion of emotion. So what is high in music? Certain tempi, certain pitch ranges, timbres, and dynamics, dependent on the genre. But of course, there's a range that is more frequently used than others, and certain extremes that are less often occurring. So this is an example then of how maybe sharp and high pitch objects are strongly associated or less strongly associated. So I think, and also bright and low pitch. Well, first of all, of course, sharp objects are quite likely to generate higher pitched sounds. So that gives a higher probability. But sharpness is maybe not so very often associated with music, except that you maybe play instruments that are with thinner and thicker strings, so that might increase that kind of association. But for brightness and colors, it's interesting that for synesthesia, that kind of prior probability might be might increase, and therefore people actually make these more are more likely to make a particular kind of associations. So then the probability of bright given a low pitch isn't very strong, but the probability of high given a high pitch would be stronger. So I think the Bayesian approach might also work here. So it considers what meanings are frequent in the context of sounds and music, as well as considering the frequency or uniqueness of feature values, and these can be genre and culture dependent. I don't think there's lots of data on this yet. And I've been thinking about what kind of data might be available to sort of go about formalizing this a bit more. So writing about music or some others, but any suggestions would be welcome here. I have a particular example to close, so some data. Yeah, and I think we have time for that. So this is a prediction of emotion and color associations in Bach's Well-Tempered Clavier Book 1. And this book consists of 24 preludes, 12 in major and 12 in minor keys, and each on a different chromatic key. And they have a range of tempi, intensities, and fluency, well, articulations, and so forth. So there are lots of different characters in this collection of pieces, but they're all for the same instrument, and there's some coherence as well. And my aim was to try to predict emotion perception from quite a simple analysis of musical cues, as well as predict color from these musical cues. And I could use data from Carol Krumhansel and her colleague Isbellen. So they have this identification of different emotions and colors with these preludes. So the emotion prediction is as mentioned before, and so what we need to hypothesize is the probability of a cue given an emotion. So for each emotion, can we say what the likelihood is of a major mode or a minor mode, as well as a fast or medium or slow tempo, or a high, low, or soft intensity. And then the probability of emotions and cues were counted from the data. So they were not hypothesized, but just from the performances that were used and the data that was given, generated, it was counted from there. So the probability of the cue given an emotion, I mean, I guess this is something that we could estimate from other data. So a second set and try to estimate this. In this case, I actually generated hypothesized numbers. So here, just the major minor mode, how likely are they to occur if it's a negative valence or positive valence or neutral valence, as well as different levels of arousal. So these are all linear kind of relationships, and some have steep slopes and others have very shallow slopes. So that's how each relationship was estimated to be strong or weak, and that's determined the slopes, and that's how these hypothesized relationships or probabilities were determined. And then some normalization to get to the actual numbers. So this was then used to, so the emotions were coded in terms of valence and arousal, and the probability of a cue given an emotion, and as well as these prior probabilities were taken to predict which emotion is observed, is perceived in each of the preludes. And these, and then the outcomes, the probabilities were then compared to the listener evaluation. So how the probabilities derived from the measured perception of the listeners. And the median correlation that between predicted and observed emotion probabilities was 0.79, which is slightly higher than predicted in another way by Carol Krumhansel. And preludes were predicted to be sad, calm, or lively. Then color perception prediction was done in quite the same way. So the probability of a cue given a color was hypothesized, and the other things were counted. So the prior probability of color and cues were counted from the data. In order to be able to predict color, we have to sort of, again, try to predict a relationship with the music, with the cues. And this was again done by using valence and arousal, but also strength. So previous research has mapped colors onto a strength dimension, so weak, strong, as well as a sad, happy dimension, which could be interpreted as combination of valence and arousal. So using that kind of mapping and valence and arousal and the cue mapping, it was possible to hypothesize and apply the Bayes rule. So a positive association between cues, valence, arousal, and strength. So for example, given high strength, there was the high probability was of high intensity was hypothesized. Again, the kind of median prediction was similar, so 79 for emotion and 0.81 for color. And of course, there's quite a lot of noise in this data anyway, so it's not possible to perfectly predicted because there's quite a lot of uncertainty between participants. So that gives sort of a ceiling for the prediction. Preloads were predicted to be yellow, blue, or red, but also ambiguous, so lots of different colors were likely. Okay, to summarize, so this is really the starting point of a direction of research that emotion and multisensory associations with music could go into, I think. It seems to me a promising method to integrate contextual factors into perception models, and it does require further development with respect to its details and define a full working methodology. And I do think it suggests certain research questions that might be of interest, including into how different cultures or different musical contexts influence the prior and conditional probabilities that people might employ. I do have some ideas about how it relates to aesthetics, but maybe that is part of the discussion. So I look forward to your comments and questions.
Thank you so much, Renee.